Можете бачити екран. Мене звати Рікардо Іверні. Я працюю в команді енергетичної статистики. Я відповідаю за статистику електроенергії. І сьогодні ми поговоримо про електроенергію і трошки скажемо про останні тенденції в електроенергії, в секторі електроенергії. Поговоримо про ключові концепції статистики електроенергії, і в нас ще залишиться час в кінці на запитання. Отож, почнемо з ключових тенденцій в секторі електроенергії. Тут ви бачите цікавий графік, як еволюціонувало виробництво електроенергії з 74-го року, коли був заснований МЕА, до 23-го року. Ви бачите, що з роком росло виробництво, крім 2009 року, коли була економічна криза, і 2020 рік, коли була пандемія. Але в цілому це призвело до підвищення в 5 разів виробництва електроенергії. Починали з 6 тисяч тераватт приблизно, тераватт-годин, дійшли до 30 тисяч тераватт-годин у 2023 році. І тут коротенькі запитання для вас. Основне топливо, яке використовувалося для генерації електроенергії у 2023 році. Подумайте і кажіть. Так, я бачу багато відповідей, і всі вони правильні. Так, вугілля, правильно сказано. Зараз у нас отут графік, який краще нам дає зрозуміти, майже за 50 років асортимент різних енергоносіїв для виробництва електроенергії мінявся відповідно до часу. Якщо ми подивимося на виробництво електроенергії з мазуту, ми бачимо, що з 25 в 74 році опустилося до менше ніж 3%. У 23 році драматичний спад. Також гідроенергетика в 23% становила 74, зараз 15%, через те, що багатомасштабні резервуари вже були використані, і, звичайно, треба інші види топлива для того, щоб замістити це зменшення вугілля і гідро. Звичайно, у нас природній газ до 22% генерації виріс у 2023 році. Також виробництво атомної енергетики з 4 до 9% виріс у 2023 році. І дуже важливо збільшення сонячної і вітрової енергії, тобто 13% виробництва електроенергії, які в 74-му році взагалі не було нічого. І за цей час ви помітите, що вугілля залишається основним енергоносієм для генерації електроенергії, і дуже за ці роки зменшилася присутність вугілля, 35-36%, звичайність, популярність вугілля – це, по суті, його переваги в ціні порівняно з іншими видами топлива. Ми глибше можемо зараз подивитися на дані по генерації електроенергії у 2023 році. Як вже було сказано, у нас вугілля залишається основний вид тепла, 35% по генерації електроенергії. Далі природний газ. У нас іде десь четверть приблизно від загального виробництва. І 63% електроенергії виробляються зі спалювального топлива. Все решта – це біотопливо, газ і відходи. Тепер давайте подивимося ми ще раз по-іншому, по регіонам розбивку. І це практично показано тут країни ОСР і не ОСР. Ви бачите, як тенденції відрізняються між цими групами. В не країнах ОСР тенденції відрізняються по регіону, Якщо ми дезагрегуємо виробництво, ми бачимо, що багато росту останні роки це був Китай і інші країни не ОСР. Але якщо ми подивимося на той самий графік, але іншу концепцію покажемо, то виробництво електроенергії в країнах, які не входять в ОСР, набагато скоріше росло, ніж в інших країнах. В результаті цього виробництво в країнах, які не входять в ОСР, в 11-му році ще перегнало країни ОСР, і з того часу воно далі почало рости. Виробництво в країнах ОСР вийшло на таке плато рівне. У 23-му році країни не члени ОСР виробляли 63% світової електроенергії. Тут ми бачимо на споживання електроенергії в світі по секторам, і ми бачимо, як споживання зросло в 5 разів з 2004 по 2023 рік, з 5 тисяч до 25 тисяч терабайт-годин. Якщо ви пам'ятаєте, декілька слайдів тому назад ми бачили, що виробництво також 5 разів збільшилося, тобто логічно, що споживання також виросло на те саме значення, але можна сказати, що все-таки цифри різні. Якщо пам'ятаєте, виробництво у 23-му році було десь 30 тисяч терабайт-годин, а тут споживання у нас тільки десь 25 тисяч терабайт-годин. А чому виникла цей розрив між виробництвом і споживанням? Ми більш детально подивимося в наступних слайдах, звідки береться ця різниця, але я так розумію, що це через втрати в передачах і в дистриб'юції, і власного виробництва в енергетичними об'єктами. Електроенергія, яка використовується, наприклад, на електростанціях, на освітлення, на інші види діяльності, і такими як в шахтах, в НПЗ, там де добувають нафту і так далі. Якщо ми подивимося на споживання по секторам, в цілому ми можемо побачити, який найбільший сектор споживання – це промисловість, але їхня частка впала через реструктуризацію і покращення енергоефективності, особливо в країнах, які не є членами ОСР, де попит в секторі промисловості росте так, як в інших секторів. Але ми можемо, звичайно, цю поведінку ще по регіонах подивитися і розбити. І ви бачите, яка відмінність між країнами, які входять в ОСР, які не входять в ОСР. Це дійсно різні. В країнах, які не є ОСР, це з лівого боку, у нас 3 сектори: це промисловість, житловий сектор, комерційні і державні послуги, і кожен десь 30%, 30-32% на себе бере електроенергії. І навпаки, в країнах, які не входять в ОСР, з правого боку в цілому, сектор промисловості становить половину практично всі споживання електроенергії. Тепер, якщо, звичайно, це поведінка може дуже сильно відрізнятися, якщо ми беремо якусь окрему країну. Тобто це були такі глобальні тенденції, концепції. Давайте ми перебудемося більш детально на концепції, які пов'язані з електроенергією, отопленням, і як звітують про електроенергію і тепло. Тобто електроенергію можна виробляти як первинну і вторинну енергію. Первинна – це, по суті, гідроенергетика, сонячна фотовольтаїка, вітрові станції і відтоки, притоки води. І вторична – це АЕС, термальні, сонячні термальні і з викопних топлив переробка. І, звичайно, це може бути первинна і вторинна енергія. Первинна із природних Це сонячно-термальні, геотермальні і
by burning combustible fuels from transforming electricity into heat in electric boilers, or using heat pumps to capture heat from low temperature sources. Let's have a look now at the producers. As you may know, electricity and heat producers can be divided into two categories: the main activity producers and the auto producers. So main activity producers generate electricity and heat for third parties as their primary activity. It means that their main purpose of the facility is to generate electricity or heat. For instance, if we think about a nuclear power plant, we have the little logo there. This is a perfect example of a main activity producer. By contrast, an auto producer generates electricity or heat only as a secondary activity in support of their primary activity. So again, another example, for instance, a large chemical facility may have an on-site power plant to generate electricity or heat for use in the production processes, and some of this electricity or heat may also be sold. However, the main purpose of the facility is to produce chemicals, not to produce electricity or heat. So that's why these would be classed as an auto producer. And it's very important because it's something that we discussed many times with our contacts, with the countries. It's important to note that this distinction is not based on whether the plants are public or private, but on their primary activity. So main activity producers and auto producers can be public or private companies. So the ownership is irrelevant. We have also three different type of plants. Electricity-only plants, which, as the name suggests, only produce electricity. We have heat-only plants, which again generates only heat. And also we have the combined heat and power plants, or CHP plants, which can generate both electricity and heat in a combined process. This distinction is important. These two distinctions that we made, so main, auto, and the three kind of plants, it's important because we have some reporting convention used in the reporting of electricity and heat statistics. And this is very important and fundamental to report correctly electricity and heat statistics. For the main activity producers, the convention is very simple. So all production of electricity and heat is reported from all plants. For the auto producer, the situation is different. So for electricity, all electricity produced is reported in the questionnaire or in the statistics. However, only the amount of heat sold are reported. The amount of heat generated for own use on site, those are not reported. Similarly, when reporting the associated fuel inputs to electricity and heat production, for heat, only the amounts of fuel input associated with heat sold are reported. So this is very important. I added a note because, like in the for the annual questionnaires, for those reporting with the annual questionnaires, in the new questionnaires, there is also the option to collect now the heat auto-consumed by auto producers. This is just a note that I wanted to add. Another important concept, which sometimes can be confusing as well, is the distinction between gross and net production. Gross production refers to the total output of electricity or heat generated in a facility before any amount of energy is used. Not all of these, of course, not all of this energy is used beyond the power plant. Some of the energy, some of the electricity and heat generated, they are used on site at the power plant for lighting, heating, supporting the plant operation. And this is called own use. So what we call net production is the difference between the gross production and the net production. And we also have a reporting conversion from own use, and this is due to the reporting conversion that we discussed before about heat in auto producers. So again, for main activity producer, the convention is very simple. The net production is equal to gross production minus the own use. For auto producers, we only report the amount of heat sold. Therefore, it doesn't make sense to speak about own use. We assume that gross production is equal to net production and that there is no own use. This is because for auto production of heat, it's very difficult to distinguish between the heat used for own use and that used support the heat supported. Sorry, the heat used to support the plant operations. Now we have covered, I would say, the tricky part of the presentation, because the reporting conventions are always very tricky and very difficult sometimes to understand. Let's have a look now to the electricity and heat supply chain and to some of the data that we collect in our questionnaires. So in terms of supply, what we collect are the fuel inputs to electricity and heat generation. Of course, the gross production. There is also the own use, the net production, which, as we explained, is the difference between gross and own use. We also collect information of the electricity used for pumped storage, hydro, for the boilers, and for the heat pumps. And finally, on the supply side, what we collect are also the trade, so the exchange, the import and exports of any country with respect to the others. On the consumption side, before the consumption side, of course, very important, we have the losses, which we mentioned a little bit before. So during the transmission and distribution, we have some losses that I will explain later more in detail. But for the final consumption, we also collect data on final consumption depending on the different sectors. Finally, we also collect data such as peak load and capacity data, which can be useful for electricity analysts. So, as I mentioned quickly before, transmission and distribution losses occur between supply and consumption, and they are responsible, like they are one of the reasons why there is a difference between the values of supply and the values of consumption. So just to give you some more detail on the magnitude of the losses that can be expected and why they occur. As electricity travels through cables and transformer, energy is lost during the way. Much of this is in the form of heat, because when electricity is flowing through the cable, it raises the temperature. This energy is lost and dissipates into the surroundings, reducing the amount of electricity that reaches the final destination. Let's say that in general, losses can be expected to be in the range from 5 to 15%, I would say. And of course, losses are lower in more advanced and well-maintained grids and higher in older or more distributed grids, or also where there is a high rate of meter bypassing, so electricity theft. This is what we were discussing before. So if we consider the global gross electricity production, we have the value of around 30,000 terawatt hour. but just 84% is able to cover the final consumption, so the demand, because around 16% is lost in the unused and losses. As we highlighted during the presentation, the difference between the gross production and the final consumption is mainly due to unused and transmission and distribution losses. Of course, there is always a statistical difference, which is the difference between the two, that can also occur. Now I would like to speak about some concepts that can be really useful as checks when reporting electricity and heat data. And the first of all is the generation efficiency. Efficiency is calculated as the total gross energy produced by a plant divided by the energy content of the fuel used to produce it. So basically, it's the energy output over the energy input. There are some rules. Of course, since energy cannot be created from nowhere, efficiency needs to be lower than 100%. The efficiency differs by fuel and technology. If you think about a coal power plant or a combined cycle power plant using natural gas, generally the combined cycle has a way higher efficiency. And it must be calculated in energy units. So what I want to say is that we need to use energy units, and we need to use the same energy units for the inputs and for the outputs. So this is a very simplified example of a power plant using 100 units of energy as input and producing 20 units of electricity and 45 units of heat as output. And the general efficiency of the plant, then it would be 20 plus 45 over 100, so 65%. It's interesting also to discuss about trade, because we have a unique reporting convention for trade in electricity. This is because unlike other fuels, trade of electricity and heat is reported on the basis of the borders crossed, not on origin and destination. This means that we include the amounts in transit. For example, if we have an export of Portugal, an export of electricity to France, it needs to pass by Spain. Portugal would report these exports to Spain. Spain would report both the imports from Portugal and the export to France, and France would report the imports from Spain. Another concept which I find useful to discuss always is the difference between energy and power. Let's say that simply put, power is the rate at which energy is used or produced, is the energy divided by time. But what I want to stress is the difference between watts, which are units of power, and watt hour, which are a unit of energy. And finally, a discussion about capacity. What we defined as net maximum capacity is the maximum power output that can be supplied on the 31st of December, so the last day of the year, of the reporting year. These are very useful data for analysts to have, but they can also be very useful for us, for statisticians, when checking the data to understand if the data reported are consistent or not. For example, we can compare the actual reported production with the maximum potential production to check if this data makes sense. This is called capacity factor. What is the maximum potential production? The maximum potential production is the production that a power plant or a country would have if producing a maximum capacity all the hours, all the seconds of the year. So it's capacity multiplied by time. It's a very useful check. Again, it should be lower than 100%. And of course, has different expected values depending on technology. For example, a solar PV, very simplifying, cannot produce at night or when there is no sun. So we would have a capacity factor way lower than a nuclear power plant, which I expect to run as much as possible, and which I expect to have a capacity factor very high, around 90%, if not higher. Just would like to quickly mention a couple of facts and information about the data collection and the types of data collection that we have. Let's say that with all statistics, data collection has a cost in terms of time, money, but also in terms of opportunity cost. Therefore, a balance must be struck between available resources and needs. This said, I like very much to stress the fact that not having the proper information available for informed decision making can lead to higher cost in the future. In the terms of specific challenges for electricity statistics, the liberalization of electricity markets has had an impact, of course, because previously, where there were monopolies, all the electricity data could be gathered from one company, but now data needs to be gathered from many different companies, and this can impact data coverage and comprehensiveness. And in terms of data collection system, to facilitate the data collection, we should, of course, establish a legal basis, establish a proper reporting mechanism, allocate proper resources, as always, and establish also a proper dissemination scheme. I will conclude with the types of data collection that you can have. We can use surveys, which are extremely comprehensive, but very often they present a high burden. They are very time consuming and they are normally expensive to manage. Second source of data are administrative data, which very often are not collected primarily for statistical purposes. They are usually collected for implemented programs or policies or for companies to run their business. But that can be really useful. For example, think about energy regulators having information on the type and capacity of the licenses for power plant that they issue, or TSO, transmission system operators, which have information on the amount of electricity passing through their networks and also across the borders. Of course, we can also gather data via direct measurements, for example, in the cases of smart meters, and this would be perfect if it would be available for all the things that we need to measure. And finally, also estimation and modeling allow to have data quantified when actual measurements cannot be obtained. If you want to learn more about the IEA energy statistics, we have a lot of different resources that can be helpful. And you will find here in the presentation some useful links to many IEA products that we publish on our website. And I would stop here in order to have some time for the Q&A.